Hello, I'm Dawn Durham, and welcome to PaTTANpod. When we think about math content and how we should go about educating our students in math, it can become a rather daunting task simply because there are so many math concepts and procedures to teach in such a short amount of time. In order to get the most out of our instructional time, we need to think about prioritizing our math content. Here to help us understand how and what to prioritize is Dr. Robin Codding. Dr. Codding, thank you for being here with us today and joining us for this conversation.
Absolutely, my pleasure, Dawn.
So let's start off by just acknowledging that math is multifaceted. There are so many layers when we think about concepts, algorithm, basic math facts, and then application of all of that knowledge. It can be quite challenging to instruct going through all those layers, could it not?
Absolutely. There isn't yet one organizational structure to help guide our instruction, assessment, or intervention services. So unlike early reading, there is no big five for math. In fact, experts suggest that the idea that we can even find one kind of indicator, like we have with oral reading fluency, is not likely to be successful in math. Instead, we have to understand the relationship between and among these different aspects of math, which in many ways researchers are just starting to unpack. So if we think about, there's a publication from 2001 called Adding It Up, and it was led by Jeremy Kilpatrick, and it defined 5 strands of mathematical proficiency. And these strands were conceptual understanding, so knowledge of concepts, number relationships, procedural fluency, the skill in carrying out procedures appropriately, accurately, flexibly, and efficiently, strategic competence, which is formulating and representing problems, adaptive reasoning, capacity for logical thought, reflection, explanation, justification. And the last one is productive disposition. So the idea that math is useful, that we can persist with our math engagement and tasks, and that we have self-efficacy around this topic. And what became really interesting about the way that these 5 strands of mathematical proficiency were depicted is that they were intertwined together to form a rope. So that suggests that these ideas are really interdependent. To follow up on that, in 2008, the National Mathematics Advisory Panel, which was again a panel of interdisciplinary experts, they reiterated that these strands of mathematics are mutually dependent and equally important. And in this case, they really emphasize the codependence of conceptual knowledge and procedural fluency. So we can see that even if math is multifaceted, there are these important relationships that we can begin to understand among these big picture ideas.
So you're saying that there's these really kind of, as you had said, we have a big 5 in literacy, but we don't necessarily have a big 5 in mathematics, but we can certainly identify that conceptual understanding, procedural fluency, strategic competence, adaptive reasoning, and productive disposition are some major buckets, if you will, of where our students need to focus their attention. And it's really about the relationship between these aspects that builds a mathematical mind.
Absolutely, that's right.
So when we think about our students who struggle in regards to mathematics and their math production or math instruction, these critical components, is this where we should be focusing on for instruction, these 5 critical components, or these 5 buckets, I'll call them, because there's many pieces and parts that go into each kind of umbrella term. So is this where we should be focusing our instruction, and how do we prioritize within these concepts?
Great. So I'm actually going to, that's a terrific question. I'm actually going to narrow that a bit. Okay. So the 5 mathematical strands of proficiency help us to understand these really overarching ideas. And then if we think about K-8 education, which is where I spend most of my time, we really want to dig into that National Math Panel report and some recent evidence a bit further. So that National Math Panel report was really interested in figuring out how do we make students algebra ready.
Algebra ready.
Yeah. And the emphasis on algebra readiness had to do with the fact that students that are successful with algebra have more success in college and have better employment earnings. So how do we help to improve our K-8 education system in that way? And what was interesting about this report is it actually further defined or refined these buckets for K-8 education and to 3 major critical foundations. And that is fluency with whole numbers, fluency with fractions, and then some aspects of geometry and measurement. So things like two-dimensional, three-dimensional shapes, using formulas to determine perimeter area, volume, and surface area. So when we think about what we know about those three areas, we can even start looking more at relationships and further revise our buckets, or narrow our buckets, if you will. So if we think about the relationship between the first two, we have some really good evidence from research groups that are affiliated with this for improving the learning of fractions. And they showed that whole number magnitude reasoning and fluency with whole number calculation is a strong predictor of fraction knowledge. So essentially, of these three critical foundations for algebra, number one and number two, fluency with whole number knowledge and fluency with fractions, are related. And it's important that students understand those foundational components of whole number knowledge in order to access fraction information.
So when you think about this being algebra ready, which I don't think is a term I've heard often before, so I'm glad that you kind of threw that phrase out there, being algebra ready really puts us on a strong trajectory for later in life, later success in school, but you said employment, and on a life path in a much stronger way. So, that's interesting to hear. And when we narrowed it down, and I appreciate you narrowing it down from these 5 buckets to a little bit more streamlined attention to fluency with whole numbers, fluency with fractions, and then geometry/measurement kind of encompassed all in there. But let me ask you this. So hearing about this, if I'm a teacher in a classroom, and this is the case for most of our teachers who are viewing this PaTTAnpod, I've got a fairly defined scope and sequence. I've got a book, and I've been told we start from here and we go to this point. And it's pretty laid out and fairly defined. So knowing what are the most critical features, as you said, the foundational skills of mathematics and their math concept to get these kiddos algebra ready, how do I go about building in, adhering to my scope and sequence, which is the parameter I'm attached to, but then really building in my knowledge of knowing I've got to prioritize certain concepts because that's going to put my students on a stronger trajectory. How do we do that as classroom teachers?
Sure. One of the great things that the National Council of Teachers of Mathematics and Common Core both have tried to do is really narrow that scope and sequence chart into driving it towards those critical features, but we can further unpack that. And we have some really good data to help us to do that so that teachers can say, all right, here's all of the things I have to cover, but here are the really important things, particularly for those students that struggle with mathematics. So I would even further divide those 3 buckets into 2 big ones, which is really focusing on whole number knowledge and rational number knowledge. A study by Bryan and colleagues in 2000 and the follow-up in 2008 actually asked teachers, in particular special education teachers who struggle with math, what did they see? And surprisingly or not surprisingly, they named 29 different behaviors. So again, goes back to that multifaceted idea of, but there were 5 things that emerged as common. And those were struggles with word problems, computing multi-step problems, math language, checking work and answers, and automatic recall of basic facts. So that can help to drive what's underneath these buckets. That, in combination with a practice guide that has been produced for response to intervention in math by the Institute for Education Sciences, which states that if students are struggling and you're providing Tier 2 or Tier 3 intervention services, you should provide in-depth knowledge of whole numbers for students in grades K-5 and rational numbers for students in grades 4. And then we can really break down this whole number and rational number bucket into 3 smaller components under each. So for whole number knowledge, we know that computational proficiency is comprised of 3 aspects: automatic recall, fluency with algorithms, and then understanding of number. So commutative, associative, distributive properties, what does an equal sign mean, early numeracy skills like counting and reasoning with composition and decomposition and place value. And we already heard about the importance of word problem solving. So if I were to create under the umbrella of whole number knowledge, and I was further going to refine that, it would look like number knowledge, or basic sense of number, number operations, that means both facts and complex number combinations, and word problem solving. And now it gets even more interesting and potentially more simplified, because when we think about rational number knowledge, which is a little trickier to unpack because the research is really emerging, we can find the same things. So the groups that are affiliated with the Center for Improving Learning of Fractions, they said, look, students need to be able to understand number operations. They have to add, subtract, multiply, and divide fractions and decimals. And they have to be able to solve word problems using rational numbers. So these same two ideas we just discussed for whole number knowledge are also important for rational number knowledge. The third bucket under rational number knowledge would be magnitude understanding. So students need to be able to represent, compare, and order fractions, decimals, and percentages. So in summary, we might think of these subcategories for whole number knowledge as number operations, or a solid understanding of number, operations, which includes calculation with both simple and more complex problems, and word problem solving. And for rational number knowledge, it's magnitude understanding, operations again, and word problem solving.
I find it very interesting as you were talking here. I'm frivolously taking notes here. When we think about simplifying, because there's such, as we had said, multifaceted, there's so many layers to mathematics and mathematical instruction, and when we think about simplifying it, what I hear you saying is that when we come together and we ask the teachers, the special ed teachers, what are we seeing, and we look at the research, we look at these scholarly articles, really we could be putting these concepts into similar relationships. Like you had said, mathematical language, that impacts your ability to process the word problems that you're doing, but then being able to understand your number operational systems and your basic whole number, rational number knowledge. All of that is encompassed in the language that you use around mathematics. But we can go even further to the relationship between you had said representing, comparing, ordering. That can be spoken to not just in decimals, but in fractions and in whole numbers and rational numbers. So there's a lot of pieces that are intertwined and tied together, is what I'm hearing you say. So perhaps it's not looking at individual concepts in silos as individual units of study, but how all of this is a big package, and really prioritizing or thinking through, if I focus my students on vocabulary, where can this impact? If I focus my students on whole numbers, where can this impact? If I focus my students on rational numbers, where can this impact? And I think we'd find if we ask those questions, it would be impacting a large majority versus this unit of study where I perhaps think maybe we focus a little bit on. Am I kind of summarizing that correctly?
Yeah.
About the intertwined relationship?
Yes, they have intertwined relationships, and also just thinking about what are the critical features under each of these bigger buckets of whole number knowledge and rational number knowledge for that K-8 instruction. So yeah, really, how do you understand what a fraction is? How do you understand what a whole number is? How do you compute with fractions and whole numbers? And then how do you solve word problems with fractions and whole numbers? And that really starts to streamline the focus that teachers need to have.
Yeah, because there's just so much, right? And we look at this and we look at 180 school days and we say, oh, we're never going to get to probability, but I know it's important because I'm over here. But it's really looking at, and as you said, streamlining our efforts and really looking at the relationship between all the components and the layers and the 5 strands, as we talked about at the very beginning. I want to ask you something. When we think about students who are struggling, particularly in the multi-tiered system of support, are there processes in place, or what can we do if we see a student who's struggling and we can get a little bit more diagnostically prescriptive about how that student is struggling or where they're struggling specifically? Do we have processes in place to look at that, or how do we look at that in a multi-tier system of support for struggling kiddos?
Yeah, I'm going to answer that question and back up one step.
Okay, please.
Before as well, because I think this is one of, so you mentioned teachers feeling stressed about how to address all of these strands that they are responsible for. And at the end of the day, it's really important to remember that there's plenty of data suggesting that with number knowledge, problems will persist throughout schooling, making it essential that these critical foundational skills are mastered. And that can be really uncomfortable for educators, because there might be a big gap between the grade level and the skill level. And so we have to understand a little bit about this research that acknowledges or demonstrates that it's okay to not address grade level when you are providing intervention services, because students will get that within their multi-tiered system. Everyone should have access to core instruction. But then we can do things in core to help differentiate instruction for those students. And their intervention efforts should really be driving be derived at these critical foundational areas. When students understand foundational skills and they are mastered, they will have the tools necessary to access that core instruction and reach those math standards. And I have three kind of pieces of evidence for that. So Matthew Burns, Amanda Vanderheyden, and Cynthia Gibbon, they published an article in 2006 that showed that classes of students who mastered arithmetic skills early in the sequence went on to master all the later skills in the sequence. That was tested in the study. But classes that did not exhibit this early mastery went on to master fewer skills later in the sequence. So really illustrating that it's okay to back up and make sure your students are understanding those key foundational skills. Another example was from Nancy Jordan and her colleagues, and this is one of those recent fraction studies from 2016. And in that, what was remarkable to me about that study is at the end, when they discuss implications for practitioners, they really urge intermediate and middle school teachers to spend more time on whole number operations. And those are not necessarily part of the math standards for a grade. But what they were finding in their research is that students came so ill-prepared, even typically performing students, in multiplication and division, that they were not able to access this fraction context. And then the National Math Panel Report highlights some important aspects of core instruction that need to maybe be addressed. One of those is that productive opportunities to practice are not built into instructional time effectively enough. And textbook examples tend not to have the types of problems that students need to see. They tend to capture more simple problems, and they don't capture the scope of problems that students will encounter. So going back now to the data and the tools that you were asking about. Educators need to be ready to use these universal screening tools and progress monitoring, and those tools can really help drive our instructional efforts. So the earlier we can capture the gaps between expected performance, the easier they are to remedy. So we can use our universal screening approach, and the evidence really suggests a gated approach might be the best idea here. So identifying, potentially through your state tests, who this larger group of students are that are at risk. And then, like you said, providing more diagnostics around where those students are struggling. What are their specific gaps? And we can do that using brief, but more specific assessments. And when we do that, it's recommended that when we follow those students, we're providing two kinds of progress monitoring for those students, that we're providing grade level progress monitoring so we can see how our intervention, which may be addressing non-grade level skills, are actually helping them to catch up on or access that grade level content. And then we need to have tools that might be considered curriculum embedded or sub-skill mastery tools, which really capture how students do on those foundational key areas.
So I want to circle back a bit because we have a lot of good information there. I want to circle back and summarize a bit of it. We talked about how everyone has access to grade level content in core. That's non-negotiable. But then when we think about differentiating instruction in our intervention efforts, that's really built into the foundational pieces that students may be lacking, as some of these reports are showing, is that kiddos are going to the middle school level not having a good solid understanding of whole number operations, which is then, of course, is causing problems later down the trajectory. So it's okay to back up to address those foundational skills, as you need that. It's kind of like building a house. You need the foundation before you can put the roof on. So those foundational skills have to be mastered. Core instructions for that grade level, but as you look at differentiated instruction intervention efforts, now we're addressing the gaps. And we talked about not having nearly enough guided practice in the classroom setting. That when we send kiddos home with homework with 32 questions, for example, and 3 were talked about in the class and the others were examples of kind of pulling all over, perhaps we're not offering our students the best practice for providing feedback to those students in the classroom. We also talked about universal screeners and progress monitoring, is identifying those kids who are likely to struggle and then perhaps going through some diagnostic testing to dig a little bit deeper and find out what's happening. Yes. Progress monitoring you had mentioned, I think that was a great point, and I appreciate you bringing that up. You mentioned progress monitoring on 2 levels. Grade level, to see if the intervention is helping them to catch up to grade level content, but also looking at more curriculum embedded pieces to see how those kiddos are progressing towards the foundational skills. So really looking at 2 levels of progress monitoring. Where are we in regards to catching up to grade level, but where are we in regards to being able to master those foundational skills? So those are those are several good pieces to bring up and to make sure that we understand. Core is grade level, address the foundational skills and intervention and differentiation, and it's okay to back up because those skills have to be mastered to put students on a solid mathematical trajectory.
Absolutely. And the great thing about these tools that we have is that we can identify individual student problems and we can identify classes of students that are behind. And so we can capture both of those fairly easily by doing that.
Excellent. We want to catch them before it's too late. We don't want to wait for them to fail. We want to identify gaps fairly quickly and immediately if we could, so that we can send the kiddos, we can get the kiddos the help and intervene where necessary. I appreciate you commenting on that. When we think about math and being so multifaceted and multiple layers, it can be quite challenging to go ahead and instruct on that. So I appreciate you helping us kind of put the math content into buckets and think about how we could streamline our efforts to ensure that we're really creating mastery for these foundational skills, so that knowledge of whole numbers, knowledge of rational numbers, puts us at this algebra ready for a strong trajectory for later on, not just in school, but beyond that. So I appreciate your time in helping us to prioritize what we need to do in the classroom, because there's a lot on us as it is.
Absolutely.
One of the things I'd like to ask, and we ask this of all of our guests, our goal with PaTTAnpod and with everything at PaTTAN is to inspire educators to grow professionally, to think about their knowledge and say, perhaps there's something I need to get stronger at, or I need a little bit more help with or more understanding. What's your advice to educators out there who are listening and viewing this program? What's your advice for them in regards to growing professionally? What would you have to say to those folks?
Sure. I think when it comes to math education and really figuring out how do we address instruction and remediation efforts, there's a lot of really fascinating emerging research that can help to guide us. And there's new information coming out all the time, which can be frustrating on one hand, but I think is exciting on the other hand. So we have to be vigilant and continue to follow the evidence regarding these critical features and foundational skills. But the good news is, and to me this is really essential, and we only got to touch on it a bit today, is that we do have these great tools, and the tools are more and more becoming refined so that we can actually use those tools to engage in universal screening and progress monitoring and engage in instructional and intervention planning using these tools. And that's really the punchline. So we can use data to make these decisions. So we do need to be familiar with what those critical foundation skills are within those whole number knowledge and rational number knowledge. We need to measure them, and we need to provide enough high quality instruction and practice to ensure that students will be able to access higher level content. And if we do that, we have a shot at getting all of our students to be algebra ready.
That's phenomenal. So you really want to be vigilant with our evidence and vigilant with the tools that are out there, because as you had said, they're becoming better and stronger and more refined and allowing us to really have the information we need to guide our instruction appropriately and best for our students. So I like that, vigilant with our evidence. I think that's something, I might have to steal that term from you. I do like that, vigilant with our evidence. You might find that I'm saying that more and more often, so thank you for that. I appreciate it. Again, Dr. Codding, thank you so much for being here with us. We appreciate it, and we appreciate your knowledge base and helping us to understand our math content and how we go about instructing our students in the best way we can. Thank you.
It was great to be here, Dawn.
Yay. Thank you to all of you in the field. You truly inspire educational growth in your students every day. A special thank you to John Ragsdale for producing this podcast. We'll see you next time on PaTTAnpod.